this video we'll be looking at 6.2, Solving Systems by Substitution. Our essential question today will be, how do I solve systems using substitution? And substitution is just that idea that I can replace a variable with a number, or in this case an expression, and then solve, and then I'll be able to solve or simplify. So let's write down our steps first. Our first step will be to isolate one variable in one equation. So we'll try to get that x equals or y equals, try to get one of those variables all by themselves, isolated, and then whatever that x or y is equal to will be plugged into our other equation. So that's step 2. Substitute the resulting expression into the other equation. So we'll take whatever that x or y equals and plug it into our second equation. Next we will solve that equation for the remaining variable. Next will be substitute the resulting value found in step 3 into one of the original equations. And then our final step will be to solve for the remaining variable. Okay, so let's see if we can do this. We have our steps. Let's try some examples. So I'm looking at this, solve each system by substitution. So I have x equals 3y minus 4 and 8x minus 3y equals 136. The first step is to isolate one variable in one of the equations. So what that means is I need to have one equation say x equals or y equals. Either one's fine as long as we have that variable isolated. So when I look here, I see, oh, this one already says x equals. So I already have one of my equations isolated. I'm ready to just move on to step 2. So step 2 is substitute the resulting expression into the other equation. So what I'm going to do is I'm going to substitute whatever this x equals. That's this idea right here. I'm going to substitute that in for x, because I'm saying x is equal to this idea. So the way we do this is I will write 8 times, and then here's my 3y minus 4. So I'll put my 3y minus 4 in parentheses. So I put 8 times x. Well, x is equal to that 3y minus 4. So there's that 3y minus 4 right there. Just getting the x is just being replaced by that 3y minus 4. And then I just rewrite the rest of this equation. Minus 3y equals 136. So now by doing this, I've turned this equation into two equations with two variables. Now I have one equation with one variable. And this we can solve. So we'll use our POM skills. 8 times 3y, so we have 24y, minus 32, minus 3y equals 136. Combining my like terms, 24y minus 3y would be 21y, minus 32 equals 136. We'll add 32 to both sides, and we get 21y is equal to 168. Oh, sorry about that. Divide both sides by 21, and we get y equals 8. So we found one of the variables, but now we have to find the other. So then we'll take this y equals and plug it into any one. Either one will give us the same value for x. It doesn't matter which one we choose. So I always like to choose the one that already has the x equals, because I'll just plug this in, simplify, and I'll have x equals. So I'm going to use my x equals 3y minus 4, and then I'm just going to take this y and plug it in right there, like so. So we'll have x equals 3 times 8 minus 4, and we simplify. We get x equals 24 minus 4, x equals 20. So now we have an x and a y, and we want to write our answer as a point. So I will say that my answer is x, comma, y. So there's my x, comma, y right there. X is 20, y is 8. So it's the basic idea behind substitution. You're replacing an entire variable with an entire idea that it is equal to. Okay, so I want to move this along, so I'm going to flip to the back and show some other kind of examples. Number 2 is very similar to number 1. We already have y equals, so we would replace this whole idea with that y and then simplify. So let's flip to the back. And on these, we'll do one of these where we actually have to solve for one of the variables to see exactly how this works. So I always try to identify which one's going to be the easiest path to solve to get a variable by itself, to isolate that variable. Well, I have 4y minus 5x equals 9, and I have x minus 4y equals 11. So which one is going to be easier to solve for isolate that variable? Well, the second one's going to be, because all I have to do is add 4y to both sides and I'll have that x equals. This one I'd have to do some major manipulation by subtracting and then dividing out, and then fractions might start appearing. So if you see a variable that's already all by itself without a coefficient, it's easier to solve for that variable. So we'll do that first. So I have plus 4y to both sides, and we'll have x equals 4y plus 11. Now I have what x equals, so I can take this idea, this expression, 4y plus 11, and I can plug it in to my other equation. So once we've isolated the variable, we take this expression, we're going to plug it in to this variable right here. We're going to plug it in right there, and remember, we'll put parentheses around it, and we'll simplify. So what that's going to look like is I'll have 4y minus 5 times. Now I have to multiply it by this entire x, so that's why I'm going to use parentheses. So we'll have 4y plus 11, and then I bring my equals 9 down. Equals 9. So equals 9 is coming from right there. So I have my 4y, my minus 5 times x, which is now 4y plus 11. We've turned the x into what it equals. And then we bring down the equals 9. And now we solve. So we'll use our distributive property. We'll have 4y minus 20y minus 55 is equal to 9, distributing a negative 5 both times. And then we'll have, combining like terms, we'll have negative 16y minus 55 equals 9. We'll add 55 to both sides, and we'll get negative 16, goodness gracious, negative 16y is equal to 64. Dividing both sides by negative 16, and we get y equals negative 4. So once you do that substitution part, it's a very straightforward solving for one variable type of equation. Now we choose an equation that we want to plug into. So we'll go back to our original equation. Again, I like to choose the one where the coefficient is non-existent or equals 1, the hidden 1, because that will be easiest to solve for. So we'll say x minus 4y equals 11. Now I'm plugging in that negative 4 in for my y, like so. So I'll have x minus 4 times negative 4 equals 11. X plus 16 equals 11. Subtract 16 from both sides, and we get x equals negative 5. And then again, we want to write this as a point, a coordinate, an x comma y. So we'll write our x negative 5 comma y negative 4, and we're done with the problem. Now I want to do one more example, but I'm going to have to manipulate one of the equations so that this works out. What I want to do is look at number 1, because we're going to run into situations like this, and sometimes these are a little tricky because they're not what we're used to, but it's still kind of the same process. So let's say instead of 4x plus y equals 6, we said this is y equals negative 4x plus 6. So what we're going to do is y equals negative 4x plus 6. And I just really want to show this because I've seen people really struggle with this idea before, so I want to make sure we touch on it. Well, if I have y equals x plus 1, and I have y equals negative 4x plus 6, I'm going to just say that I can change this y into this negative 4x plus 6. So we're going to take what our y equals, and we're going to plug it in for that y. So how this will look is I'll have my negative 4x plus 6. I am substituting negative 4x plus 6 in for this y right here. And then here's my equal sign, equals, just bringing that straight down, x plus 1. So we just turned this original y, that first y, into what the other y's equation equaled. And now we solve for this. Same process, we're solving for x, so I'm going to subtract x from both sides, and I get negative 5x plus 6 equals 1. Then I'll subtract 6 from both sides, and I'll get negative 5x equals negative 5. Divide by negative 5, and x equals 1. Once we find what x equals, we can plug it into either equation. If you look just for a second, it's often easy to see which one's the best. This one says y equals x plus 1. That looks like that's going to be pretty easy. So I'll do y equals x plus 1. I'm plugging this 1 in. So we have y equals 1 plus 1, or y equals 2. And then we'll write our answer as a point, 1, comma 2, and we're done with that problem. So just want to make sure we saw all the different kind of examples that you might run into when you start working on this material. So hopefully that's all enough for what you need. If you have any other questions, always feel free to ask. And thank you for watching this video. Hope you have a great rest of your day.